Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geek.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today this is the 24th day of our 30 days streak. Am I audible to you all? Please write a 1 if my voice is clearly audible and if I am clearly visible to you all of you. Yeah, Nakach, your attendance is marked. Okay, so I am clearly visible and audible to you all. Great. Yeah, Subham. So actually, yesterday the topic was binary search tree, or you can say binary tree. Today also I'm going to take some problems on binary tree only, so that our binary tree topic will be completed. Okay, and the rest of the rest problems of binary tree I will give as a homework today only. Okay, so that in these 2 days we will complete our binary search tree and binary tree both combined. Okay, so that is what we are going to do. Great, fine. So that's what it is. I will share the homework just after the live today. No worries, no issues. Okay, great, guys. So yeah, let me first just set up my pen tab. Yeah, great. So today the problems are, again, I have taken some basic level problems too, and I have taken then we will move on to the good problems of binary search tree. Okay, let me open the problems for today. Where's the SD sheet? Here it is. Just a minute. Yeah. So the first problem is count leaves in a binary tree. This is the first problem which we are going to discuss today. Okay. The second problem is nothing but height of a binary tree, or you can say depth of a binary tree. This is again a very important problem. How we can find height or depth of a binary tree. Okay. And at last, we will have left view of a binary tree. So these are some three problems that we will discuss today. So the very first problem is count leaves in a binary tree. Again, guys, today our topic is not binary search tree. We have discussed some problems regarding to binary search tree yesterday. Today we will be discussing about problems on binary tree. Its binary tree is going to be the topic for today. Okay, today our goal is nothing but binary tree. That is what we are going to discuss today. So let's see how many of you knows about binary tree. What is a binary tree? How many of you knows about it? Yeah, we can use level order traversal for, or we can, I think that we can use any of them, but yeah, one of which will be preferable. So binary tree is basically a tree which contains at most two children. So a tree which contains at most two children is something which is binary tree. Okay, great, guys. Now let's solve and let's continue with the first problem of today, okay, which is nothing but count leaves in a binary tree. Okay, as I told you yesterday also, the first problem which we have taken were of very basic level so that we can have an understanding of the topic, and then we will gradually increase the level of our problems. Okay, great. So let me first add the banner of the first problem that we are going to discuss, and then we will conclude it. Okay, great. The first problem is count leaves in a binary tree, which is asked in companies like Samsung and Ola. Okay, so this is the first problem. Okay, great guys. So you will get the link of these problems in the chat box. Okay, not a chat box, in the description box, and also I'm sending the link to this problem in the chat box too. Okay, so you can get access from there too. Great. So yeah, I've sent the problem. This is the problem. Okay, you can see it in the chat box. Great. So now let's start it. Let's start with the thing. Okay, I hope that my voice is now clearly audible to you all. Sorry, the screen is visible to you all. Okay, obviously. Great. So yeah, the problem is count leaves in a binary tree. So we are given with a binary tree of size n, and you have to count leaves in it, obviously. Okay, you can see that this is a binary tree. So leaves in this binary tree is just 5 and 39. So the answer will be 2. In this particular case, you will see there are 3 leaves, which is 3, 5, and 1. So the answer is simply 1. Okay. So first of all, the very basic thing that we will understand, the very basic thing is that what is a leaf? Which node is considered to be a leaf? Okay, let's say this is a binary tree. Guys, one more thing, that in a binary tree, it's not binary search tree. The values can be any. That condition is not present, that left should be less and right should be greater. Okay, that is the first case. Yeah, exactly. If left and right node. So if left node is equal to null and right node is also equal to null, that means कि a given means for a node, if its left pointer and the right pointer is both are null, that means that is a leaf node. You can see that if this is the root, so this both the values are null. For this node, all are null. Okay. So for the node whose both the pointers are null, not just one, you can see this 2, it's just left side is null. So it is not a leaf. Okay. This is how what it is. So leaf, when the left and right both the pointers are null, that means it is a leaf node. And that means we have to add 1 to our answer. Whatever is the answer, we have to add 1. So basically, if we have to find the uh, leaves for a root, so I can write that leaves, if there's a function called let's say c leaves, that is nothing but count leaf. So count leaf of root will be equal to count leaf of root left plus count leaf of root right. Is it right? Obviously, the number of roots in this, the number of leaves in this root is equal to the number of leaves in this subtree and number of leaves in this subtree. Similarly, it will just go on. Is it clear? That is what we have to implement here also. Is this particular Logic clear to you all? Okay, great. Hanji. So let's solve the problem. So yeah, I think that I think that we can return the we can use the same method for the recursive calls. So first is the base case. Base case is the one of the most important thing. Okay, that we have to do. So base case is something here which is it is if our root is null. Okay, if our root is null, so obviously we'll just return. Okay, if our root is null, so we will just simply return 0. That means no such. What is a leaf node? Leaf node is if left and right pointer are null. It's not the root. So first of all, the thing will be that if root is null, that case it will return 0. Okay. Now for leaf node, if root left is equal to null and root right is equal to null, so we will return 1. We will return 1. Okay. Now guys, after this particular case, if these both the cases are not present, so we will recursively call for, then there is a recursive function for left subtree and the right subtree. So it will return same recursive function which is count leaves and this time for root left plus root right. Okay, let's compile it. Yeah, so we are getting right answer for the given test case. Okay, for the test case which is given to us, we are getting the right answer. Let's submit it. Okay. So yeah, we have got the right answer. There were just 40 test cases and we have passed all the 40 test cases here. Okay, is it clear? Is this particular approach clear to everyone? How we are doing, how we are solving this? Is this approach clear to everyone? If it is clear, just hit the like button, okay, so that I can know. Also, we have some very few likes. So let's make like at least just 25, okay? If it is clear, there are some 30 people now. So just hit the like button so that I can know that yeah, it is clear to everyone, okay? Yeah, I'm repeating it. I'm repeating it. So what we are doing, we have to count our leaf nodes. Leaf node means that if the left pointer is null and if the right pointer is null, which node is a leaf node? A leaf node is that a leaf node is that okay. A leaf node is that whose left pointer as well as the right pointer both are null. So that is what we are checking. We are checking that if, let's say the first case is that if root is null. So root is null means there is no tree, or we can say there is nothing beside it. We will just return 0. If left and right both the pointers of the root is null, then we will return 1. If these both the cases are not there, we will return the sum of the leaves for the left subtree and the right subtree. Okay, obviously. That is a very basic and a very easy problem. Okay, a very basic approach we are used here. Is it clear to everyone? Just tell me. And then we will move towards the next problem, which is nothing but height of a binary tree. So height of a binary tree is a very important problem, and it is basically asked in many times. Okay, so yeah. Why I'm not seeing the response means there are 25 people and just I think 4 and 5 are just responding me. What about others? What about others now? You should also respond. If someone is here, it is he's explaining you. Okay. Great, yeah. Thanks, guys. Thanks. Yeah. So now this is the time for the next problem, which is the height of a binary tree. Okay. This is asked in multiple times in companies including Microsoft and Amazon. So we will have that thing here. Okay. 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 So yeah, this is the problem, which is the height of a binary tree. Let me first share the link of it in the chat box, and then we will continue. Okay, great. So this is the problem. Okay, the problem is that we are given with a height of a binary tree, and this is what we are just doing. Okay, so there can be multiple ways to solve this particular problem, and we will be focusing on a way, uh, a suitable way, how we can basically solve this problem. Okay, so we are going to solve this problem. We can say using it can be solved in different ways. Different means many ways are there, but I think that the most effective way can be traversal, and we will use in order traversal of a binary tree. So as you know that what is the in order, oh sorry, not in order, sorry, level order traversal. So we will be using level order traversal of a binary tree for finding its height. So height is just equal to the level. So it's just similar. There are some similar concepts. The level of a binary tree and the height of a binary tree. Okay, and that is what we are actually going to do here. So that's what we will do. Fine. So I hope that everyone knows about level order traversal. So that's what we will do. So yeah, let's see that how we will solve this particular problem. So let's take this binary tree only, which is given to us. So let me just make everything. Okay. It's not erasing the next thing. No worries. Yeah, I have taken up a DSE session today in a university, and I have told. I think the students are from first and second year, and I've told them one thing in the session. Let me tell you also. This is the thing which I've told them. DSA is 20% learning and 80% practice. Okay, so that's for you also. Number of levels, the height of binary exactly. Yeah, we will discuss that that what is this level order traversal. We will discuss that. No worries. Okay. So this is the route. Okay, guys, this is the route here, and we have to do the level order traversal. What is level order traversal? Okay, the level order traversal is that if we will just move on level by level. If I will write the level order traversal for this particular tree, let's see what it is. Let's see what it is. Okay, so it will be three. In first level we have three. Then it will be 1, 2. Then it will be 7, 10, and 5. Then it will be 5 and 7. This is what the level order traversal of a binary tree is. Okay, fine. Now Let's see this thing, how we can find this, how we can perform this. So for finding level order traversal, we have to take a queue. Okay, yeah, it's something similar. It's breadth first search only. Okay, yeah. So we will take a queue. We can call it BFS also. We can call it BFS also. It's just BFS. Okay, just take it as BFS. Actually, it is BFS. Okay. I sometimes, because I sometimes prefer to take traversal, to call it traversal only, but it's BFS only. Means BFS is the term which is used for trees actually, and for, oh sorry, for graphs actually. And but for trees actually we use traversal in order post also. I am just using the term level order traversal, but it is similar to the breadth first search. Okay, that's actually the same thing. काफी hard coffee है. Q. Okay. So Q, what is Q? It is first in, first in, first out. Okay. FIFO. Okay. First in, first out is what Q is. Okay. Great. Now, guys, but I think DFS is not right. Let's do this thing. Let's continue with this. I think that will take more time complexity. I think. Let's solve it using this queue. Okay, that will take order of n time and order of n space complexity. Okay, I think that is the constant also. Yeah. So great, guys. You will see one thing here, that we have the queue. What we will do, first of all, we will add this root in the queue. Okay, we will add this root in the queue. Fine, guys. So what will happen is, key, this 3 will be added, and we will increase our height. I am writing height here to 1. That, yeah, our height is 1 because we have added this 3 in the queue. So our height is 1 because we are at the first level. Fine, guys. After this, what we will do? Before, or you can say before going towards the left or right side, what I will do is, I will first take out it from start. Okay, and how many elements will be taken out? I will store the size. So you will see, just understand this thing. Okay, I have written height here. Height means that current its height is 1. Why 1? Because I am taking this 3 out. Listen, I am writing size here. What is meant by size? Size means that currently the size of this queue is 1. Means we have to remove one element from this queue. We have to remove one element from this queue. Okay, great. So it is 1. Now what I will do? We know our height is 1, our size is 1. So what we will do? We will remove one element from this queue. But after removing, what we will do? We will add its left child and its right child into the queue. So what is the left and right side of this 3? Tell me. The left side is 1, the right side is 2. So what I will do, because size is 1, size 1 means we have to remove one element. So what I will do, I will remove this 3 from here, and then I will add 2 and 1. Okay, great. This is the first iteration we have done. Now, guys, the second iteration. The second item. When we remove the, no. When we remove the element, no, this is wrong, Nakaj. If we will increase the count every time we will remove the element, so it will give us a number of nodes present in the tree. But that is not right. That is not right. Let's do this. Let's do this. Okay. Now, guys, what we will do now? Now, first of all, we will increase the height. So height will be increased to 2. Because this is the second iteration. The height will be increased to 2. Now, what is the size? Tell me the size quickly. What is the size of this currently queue? Two. Okay. Size will be 2. So that means we have to remove the first two elements from the queue. So first we have removed this 2. But as I told you, after removing, we have to add its left child and right child into the queue. So because for 2, there is no left child, we will just insert 5 into the queue. That is the right child. Now, as I told you, we have to remove 2 now. So first 2 is removed, now let's remove 1. So now 1 will be removed, and then we will insert the left and right side of 1, which is 7 and 10. Okay? Fine. And then we will again go on. Again the third iteration. The third iteration is nothing but we'll first increase the height to 3. Now what is the size? Size is also 3. Again we will remove the first 3 elements and add their childs. So 5 will be removed. There is no child of it. We will do nothing. 7 will be removed. This 7, okay, this one 7 is there, okay. There is childs of it. So when we remove 7, this 5 and this 7 will be updated. It's left and right. Then we will remove 10, but there is nothing, no child of 10. So it will be no. As per the iteration exactly. Okay. Now guys, at the last we have 5 and 7. We will again increase the height. Size will be 2. We will remove the first 2 elements, but there is no child of this 5 and 7. So the queue will become empty. And when the queue will become empty, we have to stop. We have to stop. And that's the height of it. That's the height of a binary tree. You will see that 4 is the height of a binary tree that we have calculated. How is it? How is the problem? बढ़िया था ना? बढ़िया है ना, मतलब बढ़िया है ना? Okay. Just please help me. Just please help me to solve the problem. How we can solve it? Yeah, so actually the problems are not easy. Means maybe it is easy for you, but it's a standard problem. And why I've taken this, because many of our audience is beginner only. What I have just seen this thing, that the audience which are here in 30 days streak, they are beginner. They are here to learn something new. Okay, so I'm just taking that problem that will help you guys to grow. Okay, because this is something which was a very standard problem. Okay, how we are using the BFS, or we can say level order reversal, to solve it. That's the most important thing actually. Okay, so, and that is what we have to do, and that's very important. That's very important to do and to continue. Okay, great guys. So yeah, this is all what we have. Okay. So any doubts, anyone, or we can 17 day के लाइव सेशन में किया था. Okay, 17 day के लाइव सेशन में. Okay, no worries, let's repeat it. Okay, no problem. तनय शर्मा भैया सेशन से बचा लो यार, कुछ नहीं कर सकते उसका. आई एम ऑल्सो स्ट्रगलिंग विद द सेम. ठीक है, मैं भी उससे स्ट्रगल कर रहा हूँ, बट ठीक है, मतलब अप एंड डाउन्स आते हैं. अभी अगर फ्रीजिंग चल रही है, रिसेशन चल रहा है, सो हाँ, एक टाइम आएगा कि फिर से बूम पे आएगी चीजें. ऐसा नहीं होने वाला यार कि वो इंडस्ट्री जा चुकी है. ऐसा तो है नहीं कि सॉफ्टवेयर डेवलपमेंट या टेक इंडस्ट्री, आईटी इंडस्ट्री डूब गई है. नहीं, ऐसा नहीं है. हाँ, थोड़े टाइम के लिए हायरिंग फ्रीज हुई है और थोड़ा सा हुआ है अप एंड डाउन. ठीक है, सो इट्स फाइन. देखते हैं कि कब तक सही होता है. आपको रेफरल चाहिए क्या? यार सुबह में एक्चुअली आई एम नॉट इन फाइनल ईयर एक्चुअली. मतलब मैं प्लेसमेंट के लिए तो नहीं तैयारी कर रहा हूँ. आई एम इन माई 3rd ईयर. सो अभी मतलब मुझे प्लेसमेंट होनी चाहिए, बट या ऑब्वियसली मैं स्ट्रीम में सब कुछ बातें कर लूंगा क्या? नहीं भाई, नहीं. इट्स नॉट सही कि मैं यहाँ पे रेफरल बोलूँ. बट हाँ, मैं भी फाइनल पे नहीं हूँ, तो मुझे ऐसा नहीं कि देखो मेरा प्लेसमेंट नहीं है. एंड मैंने इसलिए बोला कि मैं भी सफर कर रहा हूँ सेम चीज से. यू कैन से प्लेस, क्योंकि देखो अगर हायरिंग फ्रीज है, चीजें नहीं उतनी अच्छी हो रही, तो भी कहीं ना कहीं सबको इफेक्ट पड़ता है. फिर चाहे फर्स्ट ईयर के हो, सेकंड ईयर के, थर्ड ईयर के, फोर्थ, सबके आपको फर्क पड़ रहा है, ठीक है। हाँ, फोर्थ ईयर में जो लोग हैं उनको ज्यादा इफेक्ट पड़ रहा है, बिकॉज उनका सामने प्लेसमेंट है और उनको नई अपॉर्चुनिटीज दिख रही है, ठीक है। और जो लोग नहीं है फोर्थ ईयर के, थर्ड ईयर वाले हैं, उनको थोड़ा सा क्लोज दिख रहे हैं कि हाँ भाई हमारा नेक्स्ट ईयर आने वाला है, ठीक। और जो लोग उससे भी दूर है, फर्स्ट सेकंड वालों को फर्क नहीं पड़ रहा होगा कैसा कुछ होने वाला है, ठीक है। Exactly, others. It's all about up and down. It's all about up and down. Okay. Great, guys. Great. Okay. So I think that I think that now we can continue. Okay. Now we can continue with it. No worries. Also, guys, I think that I have not, frankly saying, I have not taken out the problems for today's homework. Okay. And because I am taking this binary tree today, so I will give the problems of that only. Okay, so I think that I have taken many problems of it. Okay, like I've taken left view of binary tree I'm taking today. I have taken check for BST. I've taken count string leaves for BST. I have taken kth largest in BST. I've taken height of a BST binary tree. Okay, there are some problems that is as lower common ancestor in a BST. Okay, LCA, which we call as LCA. Okay, so this is what, and थर्ड ईयर में कंपनी आती है, थर्ड ईयर के एंड तक, हाँ थर्ड ईयर के एंड तक, जब आप थर्ड ईयर के लास्ट में पहुंचोगे ना, लास्ट सेमेस्टर का लास्ट टाइम जब चल रहा हो तब आएंगी कंपनी। सो आई हैव 6 मंथ फॉर दैट अभी, क्योंकि मेरा पहला सेमेस्टर ही चल रहा है थर्ड ईयर का। भैया हमारी तो कंपनी कोई नहीं है रोहित, देखो हम बताएं, बहुत अपॉर्चुनिटीज हैं, ठीक है, इस आईटी सेक्टर में। अच्छा करते रहो, अपना बेस्ट देते रहो, ठीक है। मतलब अब बैठ जाओगे कि भाई अपॉर्चुनिटीज है मुझे तो मिल जाएगा, तो नहीं होने वाला। गिव योर बेस्ट, अपना बेस्ट दे दो, और देन कुछ ना कुछ हो जाएगा। अब तुम अपना बेस्ट नहीं दोगे तो दिक्कत है। कुछ ना कुछ करते रहो, कुछ ना कुछ एफर्ट्स मारते रहो। अगर कंपनी को दिखेगा ना भाई कि हाँ चलो मान सकते हैं कि काफी खराब सिचुएशन थी, बंदे को इंटर्न्स नहीं मिली, पर तभी बंदे ने कुछ किया है, उसने प्रोजेक्ट करके रखे, उसने कुछ पढ़ाया एक्स्ट्रा, तो आप तुमको जॉब देगी। समझ रहे हो? ऐसा नहीं है कि भगा देगी भाई जॉब नहीं चाहिए तुम्हारी, ठीक है, ऐसा नहीं है। एंड वैसे भी कॉलेज की मतलब नहीं है यार, हमारे कंपनी में नहीं आती। कॉलेज की तो बात ना करो, आजकल सब कुछ ऑफ कैंपस हो रहा है। आप बड़ी से बड़ी कंपनी ले लो, छोटी छोटी कंपनी ले लो, सारी कंपनियां ऑफ कैंपस हायरिंग चल रही है, तो कॉलेज कोई दिक्कत आती नहीं है आजकल। हाँ, अभी थोड़ा टाइम बहुत खराब चल रहा है, एंड अभी तो ये शुरुआत है मेरे ख्याल से रिसेशन की, और मे बी मेरे टाइम तक भी, अगले साल तक भी ये अगर कंटिन्यू होगा, तो हमें ऑब्वियस सी बात है कि प्रॉब्लम्स देखनी पड़ेंगी। बट हाँ, उसके बाद जैसे जैसे नॉर्मल होंगी चीजें, फिर से सब कुछ लाइन पे आ जाएगा, ठीक है। तो इट्स के स्विच कैसे करें? ऑब्वियसली स्किल्स इंप्रूव करो, स्विच करो। स्किल्स इंप्रूविंग योर स्किल्स इज द ओनली वे। ओके, ग्रेट गाइस। तो हाँ, तो लेट्स सॉल्व द प्रॉब्लम which is height. So we are finding the height of a binary tree. So yeah, so just please guide me how I can solve this problem. So as I told you, first of all, what we will do, first of all, we will simply take the queue. Okay, so we will take a queue. In this queue, we'll have the node only. It will be a queue of node. Let's call it queue only. Okay. So this will be used for level order traversal, or we can say PFS, anything. Okay. Now, guys, we can get, no, not on any company package. DSA is important for products, but for some startups, they more prefer development, not DSA. Okay. It can be solved by all the methods. Okay, no worries. Yeah. What I will do, I will take int. Okay, and int, you can say int h will be equal to 1 initially. Why? Because we know first thing will be if node is equal to null, means if even node is not present, so in that case we will simply return 0, that yeah, there's no height. Okay, otherwise what we will do, otherwise we will take a height is equal to 1, and this queue we will push a node. Okay, we will simply push the node. Okay, yeah, we can solve it by recursion, but recursion, the time complexity will be quite higher. Okay, I think it will be higher, or it will be, but let's go. I know that everyone can. अब मैं बताऊं, मैं लिख देता हूँ, ठीक है, मैं लिख देता हूँ कि इसका जो अप्रोच है ना रिकर्सिव, वो क्या है, देखो मैं बताता हूँ, ठीक है। इसका रिकर्सिव अप्रोच ये है return max of, let's say height is the function. Okay, let's say height is the function. So height root left plus a comma height रूट राइट प्लस वन, ये इसका रिकर्सिव फंक्शन है, एक लाइन का है सिर्फ। अब मैं एक लाइन की चीजें पढ़ाने थोड़ा आऊंगा लाइफ पे यार, इतना तो आप लोग खुद देख सकते हो और ये सबको पता होता है दैट लेफ्ट सब ट्री का सबसे लेफ्ट और राइट सब ट्री में सबसे मैक्सिमम हाइट होगी वो ले लेंगे, यही तो होता है। इसके लिए मैं वो है ना मिर्जापुर वाला, इसके लिए तो हमारे छोड़ो उसको, इसके लिए मैं लाइव थोड़ा ना आऊंगा यार इस एक लाइन के कोड के लिए। तो अगर लाइव में आ रहे हैं पढ़ा रहे हैं तो कुछ अच्छा पढ़ते हैं, ठीक है, कुछ बढ़िया वाला पढ़ते हैं जो नहीं यूजुअली यूज होता है, ठीक है, कि एक ये भी टेक्निक हो सकती है इसको सॉल्व करने की। फॉर प्रोडक्ट बेस्ड कंपनीज आई थिंक डीएसए इज मोर प्रेफरेबल, या आई थिंक कॉम्प्लेक्सिटी रिमेन्स द सेम। ओके, yeah, so now while q dot empty is equal to false, means while, or we can just simply write it like not operator, but it's fine. Okay, now guys, what we will do, as I told you, first of all we'll find the size of this queue. Okay, you can call it like sj. Now size number of times, what I will do, I will pop the element. Let's say front element is q dot pop. Let's name it q only. Then what I will do, I will push the left and we will push the right child into it, left child and the right side, and for each iteration we will increase the height, and at the last I think yeah, at the last we will return the value of x. डीएसए भी काफी कर ली है लेकिन फिर भी कुछ कोई नहीं, अब प्रैक्टिस करते रहो। एग्जैक्टली यार जीएफजी कर लो, हो जाएगा। ओके या सो मैंने गलती यहाँ पे कर दी कि यहाँ पे मुझे नोट लेना चाहिए बिकॉज इट वाज अ नोट टाइप। ओके, I always get confused between depth, size, and height. Depth is this horizontal, height is this vertical, size is size, means obviously number of nodes. Okay. ये क्या हुआ? Why it is not popping it? I think कि इसको हमें पहले front से लेना पड़ेगा, q dot front, and then we have to pop it. Okay. And height should be, I think, okay, यहाँ कुछ तो गलत हो रहा है, कुछ तो गलत हो रहा है, कुछ तो गलत। ओके हाँ, एक चीज देखो, एक चीज थी कि एक चीज हमें चेक करनी है पुश करने के पहले, इफ दिस एग्जिस्ट मींस इट शुड नॉट बी नल। इफ दिस एग्जिस्ट ना, इफ दिस, आई एम सेइंग दैट इफ लेफ्ट इज एग्जिस्टिंग एंड सिमिलरली इफ राइट इज एग्जिस्टिंग, देन ओनली वी विल पुश, अदरवाइज वी विल नॉट पुश, अदरवाइज वी विल नॉट पुश। नहीं तो वो क्या करेगा, वो सब कुछ इंसर्ट करके जाएगा, हमें रॉन्ग आंसर आएगा। Again, it should not equal to null, should not equal to null. क्या प्रॉब्लम आ रही है यार? व्हाट्स द प्रॉब्लम? Size minus minus. Thanks. 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 Okay. थैंक्स वेरी मच फॉर दिस. इट्स साइज माइनस माइनस. हाँ, एक चीज देखो, और हमारा जो आउटपुट है एक ज्यादा आ रहा है. उसका रीजन पता क्या है कि हम लोग जब यहाँ पर जब ये क्यू यहाँ पे एम्प्टी हो जाएगा ना, उसके बाद भी हाइट प्लस प्लस हो जाएगा, जो हमें नहीं करना है. लास्ट में लोग देखेंगे इफ आर क्यू इज नॉट एम्प्टी, तभी वो हाइट प्लस प्लस करे, या फिर सिंपली हम लोग यहाँ पे हाइट को जीरो से स्टार्ट कर सकते हैं. जैसे भी आप सोचो, ठीक है, कोई दिक्कत नहीं है, उनमें से आप कुछ भी चीज कर सकते हो, या फिर सीधे सीधे कर दो कि हाइट को यहाँ पर जीरो से स्टार्ट कर दो. दैट्स ऑल्सो फाइन. हाँ 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 हाँ, ठीक है ठीक है ठीक है, लेट्स सबमिट इट. क्या हो गया यार, अटक गया ये तो. रॉन्ग देगा क्या? भाई भाई भाई, रॉन्ग नहीं, रॉन्ग नहीं. हो गया हो गया. ओके. So we have solved the problem, which is height of a binary tree. It was used in many companies, like including Amazon and Microsoft, and we have solved it using the technique of level order traversal, and you can say BFS. And the time complex of the given solution is order of n, and the space complex is also order of n. So it is both the things are order of n, and we have solved this particular amazing problem. How was it? How was it? Great. Yeah, easy. It was a classical actually. It was a classical. हाँ, रिकर्जन में 2 to the power n. Yeah, we can say for every node it is going, no, 2 times. Can we space optimize? I don't think so. If we will space optimize it, it will be the time complexity will be increased, I think. If we will try to space optimize it, its time complexity will be increased. Okay, so I don't think it can be. Bit manipulation is important. Bit manipulation is very important. Okay, it's very important. Just a minute, I am just adding the taker. Just a minute. Yeah, there's the next problem. Bit manipulation is very important. Yeah, it's a standard problem. Please take right view or bottom view or top view as next problem. Yeah, we are taking left view, na. You can try right view, or right view is just similar to this. I will tell you how you can do the right view. Okay, don't no worries. I have Samsung quiz test tomorrow. How do I study at the last moment? I don't think that one night before study. एक दिन पहले की स्टडी सिर्फ होती है, आई थिंक एग्जाम्स के लिए, कॉलेज एग्जाम्स के लिए. या बिट मैनिपुलेशन इज इंपॉर्टेंट. नमस्ते सर, आपको भी सर नमस्ते. क्या सर बैठ के पढ़ाते हो? मैं भी खड़ा नहीं हो सकता. भाई मुझे मुझे बेसिकली मैं बताऊं, सो आई लव टू टू टीच वाइल स्टैंडिंग. सो मैं जब लाइव क्लासेस लेता हूँ ना, जूम वगैरह पे, और जब मेरा कैमरा ऑफ होता है, तो मैं खड़े होके और पूरे रूम में घूमते घूमते पढ़ाता हूँ. लिटरली, मतलब ईयरफोन्स कान पे होते हैं, मैं बोल रहा होता हूँ और पूरे रूम पे घूम रहा होता हूँ. ऐसा होता है. ओके. या सो वी हैव सिद्धार्थ सर हियर. सो सब लोग, लेफ्ट यू इज कवर्ड. लेट मी सी, अगर यहाँ पर राइट व्यू होता तो राइट व्यू ले लेंगे. नो वरीज. यार देखो fitness is too important. Fitness is too important. Okay, so let's take the right view यार. Let's take the right view. उसमें कोई भी difference नहीं है actually में. Same है. जैसा लेफ्ट व्यू है ना वैसा ही राइट व्यू, उसमें कोई भी डिफरेंस नहीं है सच. पीओडी रात को 12 बजे होगी. अच्छा ठीक है, लेट्स मूव टू द टॉपिक अगेन. लेट्स मूव बैक टू द टॉपिक व्हिच इज नथिंग बट द right view. Okay, I've changed it with the right view. हाँ शुभम, आपका पीयूटीडी विल बी डन. ओके, वी हैव 43 व्यूअर्स यहाँ. सिद्धार्थ भैया क्या आते व्यूअर्स बढ़ गए. सो सब लाइक कर दो यार, लाइक कर दो सब. जस्ट हिट द लाइक बटन. लेट्स मेक इट 50 लाइक्स. Let's make it 50 likes. Okay. Okay, so let's do the right view. Okay. Bottom view और top view मैं आपको होमवर्क दे दूंगा, ट्राई करना. ठीक है, चलो. Great guys. So this is the problem. It's basically कि या नहीं वो that is just valid for the long streams. Siddharth. अच्छा, so given a binary tree, find the right view of it. So right view of a binary tree is set of nodes that are visible from the right side. Okay, so okay, it's fine. Now let's focus on the problem. Okay, it's fine. So let's take the same problem which was given. Okay, and in this problem only, let's see that how we can find the right view of it. So what is right view? Let's see this this particular, let's say there's a mirror. Okay, so what you will see here, it's fine others, it's fine. अगले वाले पे हम लोग रखेंगे, सिर्फ भी अगले लोग चैलेंज रखेंगे अगले वाले लाइफ पे. 3 यहां से आएगा, 2 5 7. मेरा कॉलेज इट्स HBTU कानपुर. Okay, so this is the right view of it. Okay, is it clear? Right side. So this is the right view. Okay guys, so let's see that how we can find the right view, or similarly we can also find left view. There is just one line difference in the code. Okay, the right view and left view of a tree. Okay, so what we will do guys, we will have there will be 2 points. Will basically, the first will be level, the current level, and second will be the max level. Yeah, we can say it's left view. Yeah, so it is nothing but we can say it like key level and max level. So these 2 things will be there. Okay, yeah. So in start, if we talk, so our level will be 1 and our max level will be 0. Okay, our level will be 1 and our max level will be 0. So let me tell you why. अरे यार इसमें कौन कॉल कर रहा है? Okay, now let me add this thing. So level is 1 and max level is 0. Okay, let's see what we are doing it. Okay, so what we will do, that currently we are at root. Currently we're at root. Okay. अब देखो what we will do, as because what do you want from each level, we just want from each level what we want from each level we want the rightmost node at a particular level. So you can see that this level the rightmost node is 3, this level rightmost node is 2, this level rightmost node is 5, for this level rightmost node is 7. We have to print the rightmost node for each level. Okay, let me just make it a quite change in the tree. Let's make it 5 here. Okay, so that it will be clear. Now guys, now let's see one thing. Okay, what we have to do here. Okay. Now what we will do? So currently we're at top. Okay, which is root. So whenever our level, see one thing guys, that is a logic that if our level, whenever our level will be greater than the max level, in that case we will print the node value, and else we will just increase our level. In this case also our max level will also become the equal to level, and our level will be increased. That is the thing. Let's see why we are saying this thing, why I'm saying this thing. Okay, let's see this. So currently you will see that our level is 1 and our max level is 0. Level 1 means कि we are currently at level 1. So this is level 1, this is level 2, this is level 3, this is level 4, and let's see कि 0 is our virtual level, जो कि बहुत ऊपर है. ठीक है, तो वो क्या बोल रहा है? वो बोल रहा है that your level is 1. लेवल में मतलब क्या कि आप अभी लेवल 1 पे हो. देखो आपका जो पॉइंटर है ना, ये वाला रूट, जिसमें आपका पॉइंटर है, ये अभी लेवल 1 पे है. और आपका मैक्स लेवल क्या है? 0. मैक्स लेवल क्या डिफाइन कर रहा है? मैक्स लेवल मींस टिल विच यू हैव प्रिंटेड, आपने किस लेवल तक प्रिंट कर दिया है. सो करेंटली मैक्स लेवल इज 0 मींस यू हैव नॉट प्रिंटेड एनी वैल्यू, you have not printed any value. Now guys, you will see that this condition is true, that our level is greater than max level, कि आपका जो लेवल है वो मैक्स लेवल से नीचे है. इसका मतलब आपको वैल्यू प्रिंट करनी है, आपने मतलब प्रिंट नहीं की है. So what you will do, you will print that value. So this 3 will be printed here. So I am writing it here, the answer 3 will be printed. When we will print the 3, these two values will be updated. So this will become 1 equal to level, and level will be increased by 1, it will become 2. Okay, now next thing guys, now where we are. So see one thing here where the thing changes. Currently we have to find the right view of the binary tree. So first of all we will call for the right subtree. If we have to find the left view, so we have to call the, अरे ठीक है मैक्स लेवल, ठीक है करंट लेवल तो लेवल है ना, करंट लेवल तो लेवल है कि हम लोग किस लेवल पे हैं, और मैक्स लेवल है कि हमने किस लेवल तक प्रिंट किया हुआ है. ठीक है, सो हाँ, हम लोग पहले राइट की तरफ जाएंगे. तो अब ये पॉइंटर जो है हमें दो रिकर्सिव कॉल जाएंगे. पहला जाएगा राइट की तरफ पहले, और फिर जाएगा लेफ्ट की तरफ. अगर हम लोग लेफ्ट व्यू कर रहे हो तो पहले लेफ्ट की तरफ जाता, तब राइट की तरफ जाता. अब मैं तुमको बताऊं बॉटम व्यू क्या है. बॉटम व्यू क्या होता है? लीफ नोट्स. जिसने मुझसे बॉटम व्यू पूछा था वो क्या होता है? बॉटम व्यू मतलब क्या होता है? लीफ नोट्स ना. तो भाई क्या है लीफ नोट? मैंने भी कराया पहला क्वेश्चन, काउंट नंबर ऑफ लीफ, उसमें उनको प्रिंट करा दो काउंट की जगह. बॉटम व्यू हो गया भाई. उसमें क्या था यार? मैंने दोनों ही करा दिए. पहला क्वेश्चन क्या था? काउंट नंबर ऑफ लीव्स. इंस्टेड ऑफ काउंटिंग जस्ट प्रिंट इट, दैट इज द बॉटम लेवल. सब देखो आपस में कोरिलेटेड है. ठीक है, अब देखो we will go here. This is 2. Now for this 2 your level is 2. Again you will see your level is greater than 1. Okay, मतलब तुम्हारा जो लेवल है वो मैक्स लेवल से बड़ा है. देखो, so what it will do, it will print that 2. So again your max level will be increased to equal to level, and your level will be increased to 3. इसका मतलब क्या क्या हमें थर्ड लेवल की वैल्यू को प्रिंट करना है. Please hit the like button guys, please hit the like button. Okay, now अब यहां पर आते हैं 5. Exactly all questions are related to each other. अब देखो अब देखो पहले तो क्या करेगा, ये 3 जो है अपने राइट में देखेगा, राइट ऑफ इट, बट बिकॉज वी हैव नथिंग इन द राइट देन इट विल गो टुवर्ड्स द लेफ्ट. अब लेफ्ट में आ गया 5. ठीक है, अब इस 5 पे आ गया. अगेन यू विल सी लेवल जो है मैक्स लेवल से बड़ा है, लेवल इज ग्रेटर देन द मैक्स लेवल. ओके, सो व्हाट इट विल डू, इट विल print this 5 and then it will update the value. So this max will become 3, it will become 4. Now guys, what it will do, it will go further. So for this also level will be 2, but because currently our max level is 3 and for this the level is 2, it will not print, it will go below. Here also the level will be 3, इसका level 3 होगा. Again level जो है max level से बड़ा नहीं है. Now we will again go down. So यहां पर आता है ये राइट नोड, इसका जो लेवल है वो 4 है एंड वो मैक्स लेवल से बड़ा है. सो विल प्रिंट दिस वैल्यू 7, लेवल विल बी इंक्रीज्ड, वैल्यू विल बी इंक्रीज्ड एंड दिस इज द फाइनल राइट व्यू ऑफ आवर ट्री. दिस इज द फाइनल राइट व्यू ऑफ आवर ट्री. ओके, लेट्स quickly code it and then we will understand. Okay, because if you guys have done left view, so this is quite clear. Okay, हाँ वो भी कर सकते हैं, बट दिस इज द बेसिक थिंग ना, है तो ये लेवल और ट्रेवर्सल एक तरीके से. ठीक है, दिस इज समथिंग सिमिलर टू इट. ओके, सो फॉर दैट व्हाट वी विल डू कि वी विल टेक अ डिफरेंट, फर्स्ट ऑफ ऑल वी विल टेक अ वेक्टर answer. In this vector we insert answer and here we will have a void recursion code. Let's say this recursion, we will have a node root, a int level and a int max level. Let's write it max L. Okay, now guys, if the root is equal to null, return simply. Okay, after it what we will do, this is the base case, the basic base case. Okay, after this the recursive. So for recursive if our level is greater than our max level, as I told you. Okay, in that case what we will do, we will print that. Instead of printing here, we have to store it in the answer. I will write answer dot push back the value of it, which is root data. Okay, and after that I will make max L is equal to level. Then as it is the left view, we will right view. First of all, we will call this function recursively for right. So recursion root right comma level will be increased by 1 as I told you, and max L will be as it is. Now we will do the same thing but for the left क्वेश्चन कर रहा हूँ. दिस इज रॉन्ग. ग्रेट भाई, अगर डीएसए के साथ क्वेश्चंस बहुत जरूरी हैं. Practicing problems along with learning DSA is very important, very important. That's not wrong. It's correct. Okay, it's correct. It's absolutely correct. After which, what we can do, we can simply call this function which is recursion with the value root. 1 will be the level and 0 will be the max level. After that, we can just simply return the answer, because in our answer we will have in the answer vector we will have our answer which we have to return. Okay, so इसमें थोड़ा कुछ गलत हुआ है, पूरा ही प्रिंट कर दिया इसने. क्या गलत हुआ है यार? What's wrong here? Anyone? Okay, I think there is something which we have done wrong. This max level should be a referential value. Why? Because we will change the value of it now. So this max L should be a referential value which should be passed. Otherwise, it will not be updated for the other because it is a recursion and we are using max level. Na? Level is updated, but max level is updated in each recursive step. So we will have this as a this particular thing. Okay. So let's do this now. Let's compile it now. Okay, sorry. I think now it should be fine. Okay, again. Okay, I have to also call the, just a minute. While calling also have to give it like na, that same thing. I don't think while calling it should be same, but here it should be and of maxel. Yeah, we've got the right answer. Okay, so that's what we have. That's what we are having. How many likes are we are having? Exactly, exactly. Yeah, sorry for that. Sorry for that. Ha 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 ha. आदत, अरे स्टार्टिंग में जब मैंने 10 दिन लगातार लिया ना स्ट्रीम, तो मुझे भी आदत हो गई थी स्ट्रीम लेने की, बट फिर मेरे एग्जाम्स वगैरह थे तो फिर मुझे छोड़ना पड़ा. बट चलो ठीक है, फिर लेट्स सबमिट इट. Okay, we've got the right answer. Okay, is it clear to everyone how we have solved? And अगर मैं एक बात बताऊं, मैं अगर ये सेम कोड लूं, यहाँ से उठा लूं, सेम कोड, एग्जैक्टली सेम कोड, ठीक है, एंड मैं सेम कोड को यहाँ पर रख दूं, इस राइट की जगह लेफ्ट कर दूं और इस लेफ्ट के फंक्शन को उठा के पहले कॉल कर दूं और इसको रन कर दूं, नॉलेज तो ऑब्वियस बात इंक्रीज होगी. और ये हमारा कोड हो गया लेफ्ट व्यू ऑफ अ बाइनरी ट्री का. अरे यार गलत हो गया. चलो कुछ कुछ गलती की है क्या, क्या गलती कर दी यार, सब तो सही था. अच्छा अच्छा अच्छा, ठीक है ठीक है ठीक है ठीक है. एक एक थोड़ा सा गलत हो गया है कि हमने रिपीटेडली उसको कर दिया है. तो ये लेफ्ट व्यू है ना एक्चुअली, सो हमें लेफ्ट को पहले कॉल तो करना ही होगा. और कुछ थोड़े से और ये भी चेंजेस होंगे कि लेवल तो अप हो गया, ठीक है. एंड वैसे ये चीज़ सही होनी चाहिए, आई थिंक इट शुड बी. अच्छा, एक बार फिर से सबमिट करके वो चीज़ देखते हैं कि कहाँ पर रॉन्ग जा रहा है ना, तो उसको पता चल जाएगा हमें. Let's have it. Yeah, it is fine, giving fine answer. पता है ये क्या होता है? अब इस देखो, इसमें ऐसे कि सही आंसर दे रहा है, ठीक है, बट जब सबमिट कर रहे हैं तो इट इज गिविंग रॉन्ग आंसर. सो ये काफी ज्यादा मैंने देखा है बग यार. इस बग को मुझे थोड़ा सा बोलना पड़ेगा कि when I'm compiling it, so it is giving the right answer, but when I'm submitting the same code, so it is giving wrong answer. So ये थोड़ा सा बग है इसका, ठीक है. भैया कोई अच्छे से प्रोजेक्ट दे दो रेज्यूमे में डालने के लिए. नहीं यार, दे नहीं सकता मैं, खुद बनाओ, ठीक है, और खुद करो. हेल्प चाहिए तो ले लो. Okay guys, then I hope that today you all have learned something new. Okay, and surely we will come back with another session tomorrow. I think Gaurav is going to take the session. Okay, yeah, Nakad's great. Knowledge should be increased. That's the main objective. ठीक है यार, चलते हैं. एंड लेट्स मीट सून. कोई ना कोई लाइव के साथ मिलते हैं. एंड टुमारो आई विल बी देयर एट 10 PM on Geeks for Geeks main channel for resume review. So join tomorrow at 10 p.m. with me and Siddharth on Geeks for Geeks YouTube channel, the main channel actually for resume review. And guys, don't forget to drop your feedback in the comment section. So please आप जो भी यहाँ लिख रहे हो वो as a form of feedback comments में लिख देना. It will help us. It will help the video to be more reach. Okay. Thanks Vishal. Thanks Meskar. Thanks Nakat. Good night. Have a nice day. हाँ पूरा 1 घंटा चल जाता है और लास्ट में ठंडा हो चुका था. शुभम आप मुझे अगर आप नहीं अपलोड कर पा रहे हो आप चलो आप मुझे लिंक्डइन पे भेज देना. ठीक है लिंक्डइन पे भेज देना मैं देख लूंगी एक बार. ठीक है 25th day I think Gaurav is going to take the tomorrow's session. Okay guys, thank you. Let's meet soon. Let's meet tomorrow at 10 p.m. at Geeks for Geeks channel for resume review. I think it's 9. It's 9 p.m. or 10. मैं कंफर्म नहीं हुआ. शायद 9 p.m. है. ठीक है देख लेना जाके चैनल पे. Okay then fine guys, have a nice day. Thank you. Have a nice day. Happy coding. प्रैक्टिस करते रहो. जब जी कर लो हो जाएगा. Thank you.